Okay, so we'll start this session. So basically, today is our seventh number class. Okay, and I hope all of you already get the previous recorded video class and also get the all of materials, mainly practice code or also recorded video class. You already get all of those. So after completing the 3 hours live training, we're going to talk about the problem solving class. So let me share my screen. Just a minute. Can you see my screen? Is it visible? Okay, thank you. So let's get start. Yeah. So basically today discuss about that how we can easily make the change detection. Okay, land cover change detection using Google Earth Engine, as well as how we can easily make the NDVI change detection, mainly how we can easily identify vegetation change detection area for the different time period. Okay, or different decades, suppose 1990, then 2000, 2010, or 2020, or 2050. So different time period, how we can easily compute the change detection. It can be land use, land cover, or vegetation, or any other classes. How we can easily make the change detection, and how we can easily make the NDVI classification. Okay, so basically we already know about that NDVI range will be +1 to -1, or -1 to +1. So we can also use some threshold value and extract the different feature from the NDVI. Okay, suppose we just use a threshold value and extract the water body. We just use the positive value, suppose low positive value, it indicating about that sparse vegetation, high positive value indicating about the high dense vegetation. So this type of classification, how we can easily apply in the NDVI and identify different types of feature from the NDVI. It's called the NDVI classification. Okay, and how to extract the dense vegetation, we also discuss about that. And also class wise land use land cover change detection. Okay, class wise land use land cover change detection, how we can easily perform, we also discuss about that. And we also discuss about that calculate the transition area of land use land cover, suppose how much vegetation convert into build up, or how much water body convert into build up. So this type of transition, how we can easily compute, and also compute the transition area for the different decade. We also discuss about that, as well as we also discuss about that urban development or urban growth monitoring, such as urban expansion for the different time period. We also discuss about that. Okay, okay, just a minute, let me share my screen again. Okay, can you see my screen? I face some networking issue, so now it will be okay. Okay, so let's continue. Yeah. So let's discuss about the urban development and urban growth monitoring, how we can easily monitor the urban expansion or urban sprawl, and also discuss about the hyperparameter optimization to improving our accuracy level for the machine learning model, as well as another topic for the previous session is not completed for unsupervised learning. Okay, so how we can easily apply the unsupervised algorithm to make the classification problem. We will discuss about that. Okay. Okay, so let's go one by one. I try to discuss about that, all of those. So in the previous class, we discussed about that how we can easily compute the land image composite or annual image composite for the different time period. Suppose 1990, then 2000, then 2010, or 2020. So we already know about that how we can easily create the image composite, or how we can easily compute the annual image composite for the different year, or create the annual image composite. So in this case, for the example, I already take the two images, because I show the example using the two images. So here I already display. You can see this is the one image. This is the image for 2023, and this is the another image for 2013. Okay, this is the 2013 image, and this is another image for 2023. Okay, So then I simply use this 2 decade land images. If you want, you can also take the more image, because when you work with research paper or scientific analysis, we need to add the more data, okay, for the different decade. Suppose 1990, then 2000, 2010, then 2015, 2020, 2025, to more deeply train analysis for the land use, land cover, or urban expansion. Okay, then you try to add the more decade. Okay, but for this example, I just set only for the 2023 and 2013. Okay, so this is the image for 2013 and this is the image for 2023. Okay, and I just use these two satellite imagery, and I already make the land use, land cover map for 2 decade 2013. This is the map 2013, and this is the map for 2023. Okay, we try to create this 2 decade land use, land cover map. So if you check here, I try to classify it, mainly vegetation as a green color, water body blue color, sand land this type of gray color, and build up it's one kind red color. I just try to classify this type of land use, land cover for the 2 decade. Okay, but when you work with your research work, just try to add the more decades. Okay, try to add the more decades. Suppose 1990, then 2000, 2010. Okay, then we can get the historical data analysis. Okay, but in this example, I just set only for the 2 decade 2013 and 2023 and make the analysis. But same process you can also apply for the other decades also. Okay, when you work for your research paper or your research project, then you try to apply this type of things, increase the time period. Okay, so now if you check here, I already create the 2 decades land use, land cover classification using machine learning. So I hope you already know about that, how we can easily make the land use, land cover using the help of machine learning in Google Earth Engine. So if you check here, we create the 2 decade. This is the map for 2013, and we already create the another map for 2023. So now we are just use this 2 decade land use, land cover classification and identify change detection. Okay, as well as we also compute the transition area. We try to compute, as well as we also compute the urban expansion. Okay, so how much urban is expand, we try to compute, and also compute the urban expansion mapping. We also try to discuss about that, or also urban spiral. We also discuss about this type of things using the 2 decade land use, land cover classification map. So if you check, this is the result for 2013. Just a minute. Okay, so now we have this 2 decade land use, land cover map 2013 and 2023. So now I want to make the change detection. Okay, so let's try to discuss one by one, then you can easily get the idea and how I can create this land use, land cover map. So I hope you already know about that. Previous class I discussed about that for machine learning, how we can easily make the land use, land cover classification. Then you can also get the idea. So for that, I simply take the training sample. You can see I take the training sample for each year. Suppose I take the training sample first. I take the training sample from in year of 2013. Okay, so you can see this is my 2013 image. So just I simply use this image and take the training sample, suppose vegetation, then water, then sand, and build up. And then I just use this training sample and make the classification in year of 2013. Okay, so same process I just apply. Suppose just I simply open this map image 2023, and again I take the training sample for, you can see it, I take the training sample for the vegetation, water, sand, and build up, and then I simply make the classification in year of 2023. Okay, then we just get this map using the help of machine learning, 2 decades land use, land cover classification. So now I want to compute this change detection. Okay, for the 2 decades land use, land cover mapping. So let's try to explain, then you can easily get the idea, as well as I also check the accuracy. All of those are the similar process. So now we talk about the change detection, how we can easily perform the change detection. So change detection, it can be two type. So first type, we can say that it's a single class change detection. Okay, so single class change detection, it just talk only for the single class. Suppose I just concern only for the one class. Okay, I just work only for the one class. It's called the single class change detection. Suppose I just work only for that water body, or I want to work only for the vegetation change detection, or I want to work for water body. Okay, so it's called the single class change detection. Suppose from this map I want to make only for the urban change detection area. Suppose this is the one map, this is the another map, 2013 and 2023. So between these two map, I want to compute the urban change detection area. It's called the single class change detection. Okay, or multiple class change detection, we can apply all of class at the same time. Okay, so two types change detection, I will try to show you that in this class. So first of all, single class change detection. So in the single class change detection, first of all, suppose I want to work for build up. I want to work only for the build up class. Okay, I want to identify build up change detection between 2000 build up. Suppose I want to check for build up change detection from 2013 to 2023. Okay, so this is my main goal. I want to identify build up change detection between this time period. So for that, first of all, I need to store this map in so for that, just take a variable. Suppose I put a variable name is build up area 2023. Okay, so I create a variable. So this variable, I just store it, the build up area in year of 2023. I want to store it, the build up area in 2023. And if you check, this is the map land use land cover 2023. So this land use land cover map 2003, it is stored in a variable. Okay, it is stored in a variable. So first of all, you need to identify this variable. Okay, where is it stored? So let's check where is it stored. If you check my code, so in this case I create the 2D, you can see map.add layer function where I use. So you can see map.add layer function, classified and classified 1. So this is my variable name. So land use land cover 2023, this layer land use land cover 2023, this layer is stored in a variable classified 1. Okay, classified 1. Can you see my screen? Okay, just let me share again. Sometime it automatically stop. Just a minute. Okay. And now it's okay, yeah? Okay, so if you check, this is the variable land use land cover 2023. This map is stored in this variable classified 1. Okay, this is my variable. This variable is stored in this land use land cover map, and land use land cover 2013, it is stored in the classified. Okay, so just I simply copy the variable name because I need this land use land cover map 2023 because I want to work with that. And this land use land cover map in 2023 is stored in this variable land use classified 1. Just I copy and then paste in my code. Okay, for my, yeah, just I paste here, just paste here. Okay, so this variable is stored this land use land cover with all of classes, mainly vegetation, water bodies, sand, build up. But now I want to work with single class. I want to work only for the build up. Okay, so you want to identify what is the value or what's the level of the build up. You want to find out it. So if you check for the build up, so build up 2023, what is the level? This value is the 3. Okay, value is the 3. So I set the value build up is 3. So just I simply use in here. So just put the dot equal and set the value is 3. Okay, 3 means build up. 3 means build up. So I put. So just I simply call the classified one. This variable is stored this land use land cover. So from here I set equal to 3. 3 is indicating the level of land build up. Okay. So now what happened? So now this variable is stored only for the build up area. I want to display it. So just I put the map dot add layer and display the build up area 2023. I just simply create the binary class map. So this map display build up and non build up. Okay, build up and non build up. So binary class. So I put at the min 0 and put at the max 1. Okay, binary class, build up and non build up. So I add the color plated. So I want to put the color plate, suppose for the non build up show as a gray color and build up show as a red color. And I put the layer name, suppose urban 2023 and run the code. So now it's create the another layer for build up, only build up and non build up. Okay, then you can easily get this type of place is build up in year of 2023 and this type of place there is no build up. So we create the two class, build up and non build up. So you can see find out this type of map. Okay, so this map we can easily identify this type of place. We find out it's a build up. Okay, it's a build up and this type of gray color is a non build up. Okay, so we can easily identify build up and non build up area. We can easily get this type of place. You can see. Okay, so we find out this is the build up and non build up area. We can easily identify in year of 2023. Okay, so this is the one process to make the single class map. Suppose you want to work only for the vegetation or you can work only for the water body. So how I can create the map of water body in year of 2023? Same process, find out the water body value. Click on here, you can see water body value is the 1. Okay, so simply set equal to 1, then I can easily get the water body map. So simply put at the equal to 1. So now this variable is stored the water body. I want to show the water body as a blue color, so put the blue color and run the code. So now it's create the map of water body in year of 2023. So we find out the binary class water body and non water body, and water body region or water body area display as a blue color. So now we find out this type of blue color. We find out the water body, okay, in year of 2023, and this type of gray color display as a non water body. Okay, so this is the process. When you work with single class map, just apply the same process. Suppose I want to make the map for vegetation in year of 2023. Just let's check what is the vegetation value. Vegetation value is the 0. So just set equal to 0. Then we can easily get the result for vegetation. Just put equal to 0. 0 is the level. So in this case, we simply set here the level. Okay, level for your class. Okay, so his class you want to work. So simply set the level. So now I want to work for vegetation. Just I put here the vegetation color is the green. So now we find out that vegetation area display as a green color and non-vegetation area display as a gray color. We can easily get the vegetation map in year of 2023. And again, so we find out this type of green color. Okay, this type of green color is indicating about that vegetation area. Okay, this type of green color, and this is the vegetation area map in year of 2023. Okay, so I want to work with the build up because I want to make the urban expansion mapping. This is my main goal. So for that I simply choose the level of build up. Okay, what is the build up level? Build up level is 3. Okay, this is the build up level or value is the 3. So just I set equal to 3, set equal to 3, and I put the build up color as a red color. So this is the process to make the single class map. Suppose I have a land use land cover. So from the land use land cover, I simply choose the one class and display on my map. So then we can easily find out that only for the single class map of land use land cover classification. Okay, so after creating this land use land cover classification, single class map, so now I want to compute how much build up area or how much urban area in year of 2023. So I have to compute the area from this first layer. I have to compute the area. So let's wait and discuss about that, how we can easily compute the area. So this is my build up and non build up map in year of 2023. So now from here I want to compute the how much build up area is available in year of 2023. I want to identify this value or area. So let's go try to compute the area. So let's go try to display. So how much build up area we try to compute. So for that we need a function. We already use the function. This function called that dot image dot pixel area. Okay, so this is the function. So basically this function generate an image in which the value of the each pixel is the area of that pixel in square meter. Okay, so this is the it compute the pixel area in square meter. So we try to use the function. So for that, take a variable. Suppose I put the variable name is that urban area 2023, and then I just call this build up area 2023 because this variable stored my build up and non build up map. Just paste here and then multiply with this function dot image dot pixel area. This function we multiply. So now after multiply, we just use a function. This function called the reduce region. We already use the function. So basically this function help you to compute the statistical value using the reduce region. Okay, so this function compute the statistical value, suppose summation or maximum value, minimum value, average value for a specific boundary or a specific region. Okay, so we try to use it. Just I copy the same function. Okay, so just I use the function in here. Just I paste. So now put all of those one by one. So first argument is that geometry reducer. So just I make a dictionary, curly bracket start and curly bracket int. Okay, and then if you check the reducer, suppose I want to compute the total area of urban. So put here dot reducer dot sum. Okay, compute the total area. Geometry, it's your shapefile variable name, which is, okay, let me check the shapefile variable name is ROI. So I put the variable name is the ROI. So just I put here the ROI. Shapefile variable name, it's a boundary variable name RY. Scale is the resolution is 30 meter. Okay, and others not, and I just remove. Okay, so now I print the result. So print. So now it compute the area, how much area in urban in year of 2023. You can easily identify just on the code. So now if you check, we get the, this is the total area, but this unit is a square meter. Okay, this unit is a square meter. So now I want to convert the unit into a square kilometer. Okay, so how we can convert the unit in a square kilometer? So for that, for conversion unit, suppose a square meter to a square kilometer. Okay, so we simply convert. So for conversion, just take a variable. Suppose I put the variable name is urban area 2023. Suppose a square kilometer. You can put any variable name, and this result is stored in this variable, and it's a number. So we put here ee dot number, and then call this variable name. Okay, urban area 2023. Just paste here. Okay, and this result it get from this key value. You can see this is the key value classification. So just I use the same key value, just copy and paste here. Okay, classification, and also put the quotation start and end of the keyword and key value. Just I put at the quotation because it get from this value, and after that simply divide with 1 is 6. So now it's convert the square kilometer unit. I want to print, so print this urban area. Just call this variable and run the code. So it's computing how much urban area in year of 2023 in square kilometer unit. We find out the result. If you check, we got the result is 824.99 square kilometer area. We find out the urban in year of 2023. Okay, and this is the map. Okay, this is the map. This is the red color. Red color is indicating about the urban area, and this type of gray color it's the non-urban area. So we can get the result how much urban area in year of 2023, 824.99 square kilometer area. If you want, you can also put here, suppose just add the sum notation. So I put here the sum notation. Suppose it's a urban area 2023. Okay, so now we can get this type of notate in our result. So we find out the urban area 824 point something. This is the urban area in year of 2023. So now let's check the same things we just apply for the in year of 2013. Okay, so in year of 2013, so from this land use land cover we try to extract the urban area and also compute the area of urban in 2013. So same code we are just using here. So just let me copy the same line of code. Just I copy because we are just applying the same things. Just I copy and then paste here. So now in this case, suppose I put the variable name is I put the build up area or urban area, suppose 2013. I put the variable name look like that, and I want to identify which variable stored this land use land cover. Okay, 2013. Okay, 2013, this land use land cover is stored classified variable. Okay, classified this variable. If you check the variable name again, so if you check my previous code, we can get the classified. So this variable stored the land use land cover map in year of 2013. Okay, this layer. Okay, you can 2013. So this layer is stored in this variable. This variable name is classified. So we check this classified. So just I simply copy the variable, and now from this map I want to extract only for the urban area or build up area. So for that I need to check what's the value for the build up in year of 2013. So you can check, I just use the same value 3. Okay, 3 is for build up. So here 0 is for vegetation, or water is for 1, then 2, then 3 for 2013. Same for 2023. Vegetation is the 0, then water, then sand, then build up. We simply set. So we find out the build up in 2013 value is the 3. So just we apply the same equal to 3 and call the classified, because this variable is stored the land use land cover in year of 2013. So just call here this classified and set equal to 3 mainly for build up. So just copy, and I want to display the build up in 2013 as a binary class, and further I want to compute the area. So I put suppose build up area 2013, and then call the build up area 2013 this variable and paste here, multiply with this e.image.pixel area and compute the total area. So I want to display, just I copy and paste here. Okay, display the result, and this result I need to convert into square kilometer area. Suppose I put the variable name 2013, and then it's also just copy the variable name urban area. I want to convert this number in square kilometer unit. Just I copy and paste here. Other keep the same, and then just put here suppose urban area 2013 and call this variable name urban area. Okay, and I just have to print this 2013. So now run the code. So now very quickly we can get the another build up or urban map in year of 2013, and also compute the area urban area 2013. So it create the, I can say, 2 layer. So 2000, need to change the layer name. I don't change the layer name. So layer name we can change from here. You can see the layer name. So I put the layer name, it said 2013. So now run the code again. Check the result for the 2 decade urban map only for the build up class. So this is the result 2023. Okay, and this is the result for 2013. You can see this is the urban map in 2013, and this is the urban map 2023. Okay, so now you can see we find out that some urban is expand. We find out, you can see. Okay, so now how much area is expand of urban? We try to compute it. So you can see. So in this case, I just show the result only for the 2 decades. But if you want, you can also start from 1990, then 1900, then 2000, 2010, or 2020 to make the more trend analysis for the different decade for your research paper or your presentation. Okay, but in this case, we just work only for the 2 decade, 2013 and 2023, so that we can easily get the urban map in 2023. This is the 2023 result. And if you check, this is the result for 2013. And if you check the urban area, suppose you can see the urban area, we find out the in urban area 2013 586 square kilometer area. We find out the urban, and 2023 we find out that 824.99, and 2023 and 2013 we find out the 586.44. Okay, so almost how much area, just simply subtract this 2 value, then we can easily get the how much area is increased. We find out the 238.55 or something, 238 point something square kilometer area is increased between this 2 decade 2013 to 2023. We find out that how much area increased. We find out the total 238. Simply subtract this value and this value, then you can get the result how much area is increased between the two decades. So we find out that 238 square kilometer area is increased. So now I want to identify, so you can see we can get this type of map, but I want to identify urban changed map. So how I can make the urban changed map? Okay, you can see. So we find out that some new urban is increased, you can see. Okay, some new urban is increased in year of 2023, but 2013 you can see some place, this type of place there was no urban area, this type of gray color. But when I open the 2023, we find out the some urban area. Okay, it increased, you can see it increased. So I want to identify, suppose urban change map. Okay, if you check some place, suppose this type of place, it was urban in 2013, and 2023 it also urban, there is no change. Suppose for this type of place, this type of red color, it was urban in 2013, and 2023 it also urban. So it means that there is no change, it's the unchanged place of urban. But we find out the some place, suppose this type of place, there was no urban, there was no urban in 2013. Okay, so but 2023 we find out the urban, this type of place. So this is the urban changed area. So now how I can create this type of map, changed and unchanged area? So it's very easy for creating the changed and unchanged map of urban. You just take a variable. Suppose I put the variable name is that urban changed map. Right? Then I put here, call the build up area 2023. So this is the build up area 2023. Just I copy the variable and then paste, and it's subtract with 2013 build up area 2013. Just I copy and paste here. Okay, very easy. Just I call the build up area 2023, basically this map 2023, this map, and also call subtract with this map 2013, this map. Okay, simply call. So now we are going to display the changed and unchanged area. So for that, just add the layer. So map dot add layer, and just call the urban changed map. Okay, so we create the binary class. So binary class basically mean I put the 0 and max for 1 for the binary class, and put the plated color plated. So changed and unchanged. Okay, so where there is no changed, so I want to display is as a suppose white color. Okay, so white color indicating about that there was no changed or unchanged area. Suppose in year of 2013 I find out the build up for this place, and 2023 I also find out the build up. It means that there is no change, it's the unchanged area of urban. And where urban is changed, I want to display as a suppose as a red color. Okay, so this is the changed area. Suppose in the red color there was no urban in 2013, but 2023 we find out the urban, this type of red color place. So I just put the layer name. Suppose I put the layer name, it's a urban changed map, run the code. If you check, we find out the white color. So in the white color, it means that unchanged area. Okay, it's the unchanged area. But we find out the newly set up urban area, this type of red color. Okay, it's indicating about the newly set up urban area. So there was no urban in 2013, but 2023 we find out the urban area, this type of red color. Right, this type of red color. So it's a newly set up urban area. Okay, but this type of white color, it's the unchanged area. There is no changed this type of white color. Suppose it was urban in 2013 and 2023 it also urban, so it means that there is no change or unchanged area. But this type of red color, it's indicating about the changed area. Okay, so there was no urban in 2013, but 2023 we find out the urban, this type of red color plus. Okay, so this is the urban changed map. And how much area we find out the urban, how much area we find out the urban. So it's indicating this value. Okay, simply subtract this value 2884.99 to 586, then we find out that how much area we find out the urban. Okay, 238 point something square kilometer area we find out the urban in year of 2023. But this 238 square kilometer area was not urban in 2013. Okay, so we find out the urban, this type of urban area, 238 square kilometer urban area we find out in year of 2023. Okay, so this is the urban changed map. So this thing you can also download. So all of layer we can easily export as a GeoTIFF file format. Okay, for our research paper. So if I show you some research paper, then you get the better idea. Okay, so let me just let me open and show you that. Just a minute. So just I simply open Google Scholar. Let me open. Okay. So if you check the urban expansion, simply search on the Google class for urban expansion remote sensing. If you check, this is the one paper monitoring urban expansion with remote sensing in China. Let me open and show you the result. So if you check, uh, where is the paper? Oh, it's not free. Just a minute. Let me check the another paper. So this is the analysis of land use, land cover change, and urban expansion in the Nairobi city using the remote sensing GIS. If you check this paper, this is another paper. So a special temporal urban expansion in the Pune metropolis, India, using the remote sensing. So now you can see they are used the time period 2001 2013 in comparison 1992 2001. These two time period we try to use in here. Also, if you check this is another paper. So in this paper, Urban quantify the spatial temporal patterns of the urban expansion in China using the remote sensing. So you also tried a lot of paper, you can easily find out this type of topic to identify urban expansion or urban sprawl, okay, for different time. Okay, then further if you want you can also work for any project, and further you also try to for the publication easily using this type of concept, urban expansion, urban sprawl mapping, you can easily get. And if you simply search here, suppose uh, urban expansion map, so you can easily create this type of analysis after downloading the GOT file format, okay, for the different decade urban you can easily identify. So in this paper, basically they make the land use land cover for 1998, then 2008 and 2018. Okay, for the make the land use land cover classification maps for their study area, and further they make the urban expansion against the urban growth map. Okay, for this 3 time period they're also using here. So I'll send you this type of reference paper also. You try to read, then you get the more idea about the urban expansion or urban sprawl, how you can easily work using the remote sensing, then you can get the idea. So now we create this type of things. It's called the urban change map. Okay, how much I had the newly set up urban, you can also get it. And if you want, you can also export all of maps. Suppose in this time, this map. Okay, so in this case, I just work for the 2 decades. So simply export this type of GOT file format and display the urban expansion map. Okay, urban expansion map in ArcMap software. Okay, just simply add all of layer. Then we can easily identify urban expansion map, okay, for the different year or annual urban expansion map. We can also display. This thing is also possible to display in here also. So I will show you this concept also, how we can easily display the urban expansion. Suppose then I can easily get the idea this urban is for year of 2013, another urban is for the 2023. Okay, so then we can easily get the idea, or a special distribution of the different annual urban, we can easily get the idea. So for that, just simply apply the self marks function. Suppose we are just call, if you check the build up area, so just apply the self marks, use at the self marks function. Okay, so when I apply the self marks, then we need to apply the single class, not binary 0 and 1. So we are just put the single class. So now simply remove the make, mean and max after applying the self marks, if not need. So just I remove the gray color and I display only for urban area in 2023 as the red color. Okay, and for the another urban area in 2013 I display the another color. So for that, just apply the self marks and I display the another in yearly urban. Suppose just make the single class, remove the binary class, is not need. I need to display it with another color, suppose as a yellow color. So I put here suppose yellow color, yellow color, yellow color. So now I find out the urban expansion in 2013. This type of urban show as a yellow color, and 2023 this type of urban show as a red color. Suppose you have the other urban map also, suppose 1990 or 2000, 2010. So just same process, just apply the self marks and use the different color to identify different yearly urban. Okay, so in this case I have the two map, 2013 and 2023. So just let me display the result. So now run the code. Now you can easily get the idea. Okay, just I open this two layer, okay, of urban. Okay. So now if you check, we find out the result. This type of yellow color, this type of urban, it was in 2013. Okay, and this type of red color urban, it show the result in 2023. Okay, if you want, you can also add the more others, suppose 2000, 2010 or 2025. Okay, different decade, then it will be look more perfect. For the urban expansion, yearly urban expansion, you can easily get the idea. Suppose 2000, suppose we find out the another color for the 2000, then 2010 it show the another color. So now this type of yellow color, it's indicating about that urban in 2013, and this type of red color, it show the urban in year of 2023, and it indicating about the urban spiral. Okay, urban spiral for the different time period or annual different year. So I also put the assignment, you also try to do this type of for your area. So you take the land use land cover, suppose from 1990 and up to 2025. Okay, suppose 1990, then take the result for 2000, then 2010, then make the result for 2020, and finally 2025. Okay, or also get suppose start from 2000, suppose okay, let me show the assignment also. Write the assignment. Suppose you try to 2025, then make for 2015. Okay, then make for 2005. Okay, then make for 1995. Okay, suppose you take the annual composite for 2025, 2015, 2005 and 1995, and make the land use land cover classification, make the LULC. Okay, and from the LULC extract only for the urban, extract only for the urban area. So then just make the urban expansion map. Okay, or also compute the urban area. Okay, how much area increased. Okay, suppose how much area 1985, how much area 2025. So how much increase, or what's the percentage of increase the area. Okay, so it also more better. So further, if you want, you can also write all of those properly, then you can easily submit for any journal. I can also publish the scientific paper related to the urban expansion or urban spiral mapping. Okay, so using the same process, but before that, for this type of annual 1985, 2005, 2015 or 2025 or any time period, you can choose based on your study area, and then make the land use land cover. Further make the urban. Okay, just simply make the urban expansion for the different year. Okay, and finally export this type of layer, and then work with ArcMap or ArcGIS software to produce your map for your presentation. So I also send you some reference paper related to the urban expansion mapping. So you also try to follow it, and further, if you want, you can also make the analysis, and further you can also submit your paper for the urban expansion or urban growth monitoring. You also do for the different time period. Okay. Okay, anyone, any question you can ask me about this topic? Any question you can ask me, please. Yes, please. Kindly mute.
Hello,
Yeah,
sir.
yeah,
Can you
please.
hear me, sir?
I can hear you, please.
Okay, sir. Actually, sir, in some research papers recently, I have seen they have adjusted some significance level while categorization of their classes are, for example, like vegetation, and they have categorized significant increase, significant decrease,
Yes, yes.
significant negative increase, positive increase, and they have also placed some p-values like is significant, p is less than 0.05.
Yeah.
So how they adjusted such type of significance level?
Okay, I understand. Yeah. So it also possible
Yes.
for the significance level, how we can either identify. So we can add the different types of variables. Suppose I just make the NDVI map, or suppose I just make the map, suppose 2025 1995 to 2025 2025 2025. So from this time period I want to identify, suppose for this study area where the vegetation significantly increased. Okay, vegetation suppose increased, okay, significantly increased or significantly decreased. Okay, so it's called the your trend analysis. Okay, trend analysis. Okay, and this trend analysis we can apply for raster imagery. Okay, raster imagery. So in Google Earth Engine there are the two options. One is for linear trend analysis we can apply. Another is called the man candle analysis. Okay, so these two analysis you can easily apply. Suppose first of all you need to make the NDVI map or vegetation map between this time period, okay, or annual NDVI map from 1992 to 2025. Okay, just make the map. After that simply need to apply the linear trend analysis and also apply the man candle analysis. Okay, if you check, simply check some function. If you check, click on here, simply search here man candle. So you can see this is the not man candle, man. Yeah, candles correlation. Okay, so the candles correlation. So if you check, it's compute the candles tau b rank correlation. If the positive value we find out, it means the indicate the increase the trend. Suppose I just apply this function in my NDVI and I find out the positive value, it call the increase the trend. Okay, and also find out the negative value, it call the decrease the trend. Okay, so this thing you can also get in my some resources. I also show you that. You also try to follow, and then you can easily create this type of tau candle or linear regression. You can easily do it, no problem. Okay, so just a minute, I'll show you the some system. Okay, so okay, you can also follow this tutorial, then you can also get the idea how to apply the vegetation trend analysis. Okay, recently I also make the one class for my advanced training session for research based. Okay, so I also send you this link. You also try to follow this link, then I hope you can easily get the idea how to work with the vegetation trend analysis. Okay, so where is the increasing or decreasing or significantly increasing or significantly decreasing. So this type of idea you can easily get the from this session. You can also get the idea. Okay, just follow this. I hope you can easily get the idea how we can easily identify the vegetation trend analysis. Okay, where is the significantly increasing, significantly decreasing, how we can easily compute the linear fit model or linear equation y equal to mx plus c and make the trend analysis, or how we can easily make the tau man candle tau. So this type of thing you can easily get it from here. So also try to follow this tutorial, then I hope you also get the idea for the vegetation trend analysis for the different time period. Okay. Okay, so we find out this type of urban change and we find out the urban expansion mapping. So you also try to create this type of different year of your land use land cover, and further also identify for urban trend or urban expansion, also compute the urban area Okay, so how much urban area increase or decreasing. So we also try to identify using this way. Okay, so I hope you also get the idea how to work with urban expansion or urban monitoring or urban development, okay, for the different time period. Just apply the same process and also work for any study area. So now we talk about the multiple change detection. Okay, so it's called the single change detection. Just I talk only for the build up and work, but I want to do for multiple change detection. So what is multiple change detection? So at the same time, all of class I just consider and make the change detection at the same time. Okay, so when you apply the multiple change detection, first of all, what first step you need to make the reclassify. Okay, reclassify basically, suppose reclassify, I have some value, you can see 0, 1, 2, 3. Okay, so this type of value I simply reclass, I make the another value. Suppose I put the 0, it will be 1, 1 will be 2, 2 will be 3, 3 will be 4. So vegetation is 1, then 2, then 3, and then 4. So now I reclassify 0 to 3 into suppose 1 to 4. Okay, so this is the main target. So first step, reclassify land use land cover map. So this is my land use land cover 2 decade 2023 and 2013. So these two land use land cover I simply reclassify. So how I can reclassify? So this type of 0, 1, 2, 3, it will be 1, then 2, then 3, and then 4. Okay, so I just reclassify for the two land use land cover classification map. So for that, just take a variable. Suppose I put the variable name is suppose before class. Okay, and then call the land use land cover. So I work with before class 2013. Okay, just call this variable name. Which variable stored this map? Okay, which variable stored this land use land cover 2013? So find out the variable name. So this variable name is the, okay, let me check again, you can check. So this variable is classified. Yeah, classified. This variable is stored the 2013. So just I call the variable name classified. And then paste here. Okay, so I need to reclassify. Okay, so just put it the remap function for reclassify value. I want to reclassify the value. So my previous value was 0, then 1, then 2, then 3. But now I want to set the new value. So put here the new value 1, 2, 3, and 4. So now when I apply the remap function and this remap, so 0, it will be 1, 1, it will be 2, 2 will be 3, 3 will be 4. Okay, so I just remap the reclassify and store it in this variable before class. So now this before class, it stored the value for vegetation is 1, water body is 2, sand land is 3, and build up is 4. Okay, same process I just apply for the another land use land cover in 2023. So if you check 2023 this land use land cover, so it is stored in this variable classified 1. Okay, this variable is stored the land use land cover map 2023, and just I simply make the reclassify. I put the variable name, suppose another variable, suppose after class. Okay, so first step, reclassify, we simply change the value. Okay, and now we need to make the change